So we're talking about quadratic functions, and I want to relate two things. One is that a parabola, which is what we see here, it's the graph of a quadratic function. So there are a couple of ways to look at this. I feel like there's a lot of information, especially on this page, to talk about quadratic functions. So we've seen ax squared plus bx plus c. That's a quadratic function. We can express this same thing in this form here. This is the standard form of a quadratic function, and it involves some completing the square, which I know that you may not have enjoyed that section when we covered it, but f of x equals a times x minus h squared plus k, where hk is the vertex. Now the vertex, here's a vertex in this case. So parabola, it's either going to open up, and the vertex is the low point, or it opens down, and the vertex is the high point. So vertex is going to be the low point or the high point of a parabola. Now, if it's opening up, it goes up forever. If it's opening down, it goes down forever. I think I'm getting out of the screenshot here. And the point I want to get at is, if you can get it in this format, you know the vertex. It's not hard to get there, and we talk about that. So the vertex is the highest or lowest point of a parabola. Zeros are the x-intercepts of the graph, so that's where it hits the x-axis. Those would be zeros. So they'd be like taking ax squared plus bx plus c and set it equal to 0. So that means y is 0, and y is 0 on the x-axis. We also have something called the axis of symmetry. That's the line of symmetry for the graph that goes through the vertex. And it's going to be a vertical line because we're dealing with a function here. And you may have seen parabolas on their sides. They're not functions, but they would have an axis of symmetry too. So there's the axis of symmetry. And so that's going to be a vertical line. X equals whatever the x coordinate is for the vertex. So here's our example 1. Determine the vertex, the axis of symmetry, the zeros, and the y-intercept. So our vertex is this point down here. Let me change my color to go red. So it's right down here. So it looks like it's 3, 1. Okay. And the axis of symmetry is that vertical line that goes through there. So x equals 3. Now, when it asks for zeros, that's where it crosses the x-axis. It's not crossing the x-axis, so there are no zeros. In fact, if you were to find zeros, if you got the equation of this and set it equal to 0, they'd be complex numbers because they'd have some zeros, but they're not real. And the y-intercept would be where it hits the y-axis, so that's right there. So the y-intercept is going to be at 0, 7. Okay. So forms of a quadratic function. So here's another version of one. There's a vertical, there's the axis of symmetry. It opens down, so vertex is up here. Quadratic function is a function of degree 2. The graph of the quadratic function is a parabola. The general form of the quadratic function is f of x equals ax squared plus b, x plus c, where a, b, and c are real numbers. And a is not 0. And this is the standard form, which just kind of restated what we already had stated. And let's talk a little bit about the vertex, how to find it. So if you know hk, that's great. That's your vertex at hk. But if you don't, you can find it by doing h is, if you have it, f of x equals ax squared plus bx plus c, then negative b over a will give you your h value. I think that should be negative b over 2a. There we go. Negative b over 2a. And then your k is f of h, which is f of negative b over 2a. So negative b over 2a would give you the k value. How to write the equation of a quadratic function in general form. Identify the horizontal shift of the parabola. So if you have y equals x squared, how is it shifted? horizontally, that's your h value. Identify the vertical shift, and that's your k value. So your standard one, that vertex is at 0, 0. Substitute the values of the horizontal vertical shift for h and k into the function f of x equals a times x minus h squared plus k. Substitute the values of any point other than the vertex on the graph of the parabola for x and solve to see what kind of stretch factor. So, it should go through 1, 1. If it goes through 1, 2, that means your a is a 2. If the parabola opens up, a is positive. If it opens down, a is negative, since it means it's reflected about the x-axis. Expand and simplify to write in general form. So that's going from standard form to general form. So write an equation for the quadratic function g in the graph as a transformation of the function f of x equals x squared, and then expand the formula and simplify terms to write the equation in general form. So right off, we can see our g of x. It's going to be a times, what's happening to the f? Oh, I should just do, say f of x minus a negative 2. So I'm looking at this. Vertex is at, we have negative 2 comma negative 3 minus 3. So it's a times f of x plus 2 and then minus 3. So we have a times x plus 2 squared minus 3. Because what is f doing? It's squaring something. So before I expand it, let me see if I can come up with a. So normally we'd go over 1, up 1. Now we're going over 1. It looks like it's at half. It's gone up by half. And then if we went over 2, up 4, we're going over 2, up 2. So I'm looking at how it's growing. It looks like it's growing half of what it should be. So I'm thinking a is 1/2 in this case, but it's opening up so it's positive. So our g of x is equal to 1/2 times x plus 2 squared minus 3, or 1/2 times x squared plus 4x plus 4 minus 3, which is 1/2 x squared plus, I'm distributing the 1/2, 2x plus 2 minus 3, or 1/2 x squared plus 2x minus 1. That would be the general form. Okay, moving on to finding the vertex. So identify a, b, and c. Find h, the coordinate of the vertex, by substituting a and b into h is negative b over 2a. Find k, the y coordinate of the vertex, by evaluating k equals f of h. Okay, restated the same thing we said. So what is the vertex of this one? Well, it's going to be, h is going to be negative of negative 6. Our b is negative 6. Our a is 2. Negative 6 over 2 times 2. So that's going to be 6 over 4, or 3/2. And our k is going to be f of 3/2, which is going to be 2 times 3/2 squared minus 6 times 3/2 plus 7. So we have 2 times, that would be 9/4 minus 6 divided by 2 is 3. So minus 3 times 3 is 9. Oh, change colors. 9 plus 7. So the 2 and the 4 here reduce. That makes that a 2. So we end up with 9/2 minus 9 minus, so negative 9 plus 7 is negative 2. So minus 2, so that's 4/2. So I get 5/2. Okay, so now we need to simplify this and turn this into the other form. Okay, so the pieces are all here. We see our a is 2, as we already identified. So our f of x is going to be 2 times x minus our h. Our h was 3/2 squared plus k, which is the 5/2. And that's it. Next video, domain and range.